A physicist is a scientist trained to understand the interactions of matter and energy across the physical universe. Physicists study a wide range of phenomena in many branches of their field, spanning all length scales, from subatomic particles of which all ordinary matter is made, to molecular length scales of chemical and biological interest, to cosmological length scales encompassing the universe as a whole. Physicists generally are interested in the root or ultimate causes of phenomena, and usually frame their understanding in mathematical terms. The term physicist was coined by William Whewell in his 1840 book The Philosophy of the Inductive Sciences. Education. The material a student encounters in the undergraduate physics curriculum is based on an intellectual ladder of discoveries and insights from ancient times to the present. Many mathematical and physical ideas used today found their earliest expression in ancient Greek culture and Asian culture, as well as the Islamic medieval period. However, the bulk of physics education can be said to flow from the scientific revolution in Europe, starting with the work of Galileo and Kepler in the early 1600s. Newton's laws of motion and Newton's law of universal gravitation were formulated in the 17th century. Maxwell's equations of electromagnetism in the 19th century, and quantum mechanics in the early to mid-20th century. New knowledge in the early 21st century includes a large increase in understanding cosmology. The undergraduate physics curriculum generally includes the following range of courses: classical mechanics, astronomy and astrophysics, physics laboratory, electricity and magnetism, thermodynamics, optics, modern physics, quantum physics, nuclear physics, particle physics, and condensed matter physics. Undergraduate physics students also need mathematical training in calculus, differential equations, linear algebra, complex analysis, etc., and also in computer science and programming. The goal of undergraduate education is basic competence in all areas of physics endeavor. Undergraduate physics students sometimes perform research with faculty members. Many positions, especially in research, require a doctoral degree. At the master's level and higher, students tend to specialize in a particular field. Fields of specialization include experimental and theoretical astrophysics, atomic physics, molecular physics, biophysics, chemical physics, medical physics, condensed matter physics, cosmology, geophysics, gravitational physics, material science, nuclear physics, optics, particle physics, and plasma physics. Postdoctoral experience may be required for certain positions. Honors and awards. The highest honor awarded to physicists is the Nobel Prize in Physics, awarded since 1901 by the Royal Swedish Academy of Sciences. Employment. The three major employers of career physicists are academic institutions, government laboratories, and private industries, with the largest employer being the last. Many trained physicists, however, apply their skills to other activities, in particular to engineering, computing, and finance, often quite successfully. Some physicists take up additional careers where their knowledge of physics can be combined with further training in other disciplines, such as patent law in industry or private practice. In the United States, a majority of those in the private sections having a physics degree actually work outside the fields of physics, astronomy and engineering altogether. Nobel laureate Sir Joseph Rotblat has suggested that physicists going into employment in scientific research should honor a Hippocratic oath for scientists.